All right, so for this question, we are asked to factor out the greatest common factor. And in this one, it doesn't, the greatest common factor might not look like you expect it to. There's a grouping in each of these terms. Okay, so we have two terms. Well, first of all, terms are separated by pluses and minuses. Okay, the plus sign or the minus sign. So we have two terms here in the way that this expression was given. The first term is 3 times a plus b. That's all one term. The second term is 9m times a plus b. And the two terms have one factor. Now, what are factors? Factors are separated by which mathematical operation? Multiplication. Okay, so then this term has two factors, right? One factor here and another one here. The second term has a factor here and a factor here. So looking at the two terms, what do they each share as a factor? The first term has the factor a plus b quantity, and the second term has the quantity a plus b as a factor. So that is the greatest common factor because, well, it's not the greatest. It's part of the greatest common factor. I just noticed there is something else here. Notice that 9 can be broken down into factors 3 times 3. So because of that, let me just break it down like this. We can take one of those 3's and match it up with this 3 over here. Okay, so starting back at the original, we had all this, right? And so we can take out the common factor. The GCF is going to be 3 times a plus b. And when we factor that out, what will we be left with? So 3a plus b, starting over from the beginning, 3 times a plus b plus 9m times a plus b. We can rewrite this as 3 times a plus b plus 3m times 3a plus b. And then we see that this and this are common. And when we factor them out, what do we get? We get, let's take out the common factor, 3a plus b. And then when I take that out of the first term, the only thing left in the parentheses will be 1. Then the plus sign here. And then the 3m. Okay, so just picture a 1 here. Okay, so that is why the answer makes sense. Actually, I think I'm going to go on and answer another question in here. What's the next one? How to factor the polynomial x to the 4th minus 81. The trick is to think of it as a quadratic equation. Okay, so you have this to the power of 4, or that's not what I meant to do, to the power of 2, right? X to the power of 2 raised to the power of 2 will give you x to the power of 4. And I just rewrote it in a way that I can think of this as quadratic in form. And then I can rewrite the second part of this as negative 9 squared. So that means that I have a difference of squares. And I know difference of squares, let's just review the difference of squares. Difference of squares pattern. This is something we notice, that when we have a squared minus b squared, it'll factor to two binomials, a minus b times a plus b. Okay, so that means that if I think of x squared as my a, okay, what's inside of here, and if I think of this as my b, then I can follow the pattern. That will be a minus b, so a is x squared minus 9 times a plus b. Okay, but that's not all. This one right here actually turns out to also be a difference of squares, so that can factor out. What's the square root of the first term? That's x. What's the square root of the second term? That's, or not the whole term, but just the 9 part. That's 3. So I can rewrite that little part as x minus 3 times x plus 3. Now there is no sum of squares pattern. Sum of squares does not factor. So that's why the correct answer is this one. And finally, this one's a fun one too. Look, we have quadratic, but let's set it equal to 0 by subtracting the 19 so that we can use the quadratic formula. Now you can do it like this, or you can multiply everything by a -1 if you prefer not to have a negative out there. If you multiply everything by a -1 on both sides, then the -1 will distribute and all the signs will change. And then 0 times -1 is still 0. So it's not necessary to do this step, but it feels a little cleaner. But whether you do that or don't, you should still get the same answer. All right, so now we're going to use the quadratic formula. You could try to factor this, but I'm just going to go ahead and use the quadratic formula. So remember, the quadratic formula says that when you have a quadratic, let's use a different color. The quadratic formula says when you have, this is only when you have this format of a quadratic, then you can find the solutions using -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so then here, since we already have this thing set equal to 0, we can see that a is going to be 4, b is going to be -16, and c is going to be +19. So now we'll go ahead and we'll start setting up our shell b, -b, plus or minus square root of b squared minus 4ac all over 2 times a. Okay, so let's put in the a value is 4. I'm going to put that right here and here. The b value is -16, so let's go ahead and put that here, -16. Don't forget we already have a negative outside of it, so this is going to become a plus. And then we have -16 in here, and then when you raise something to the power of 2, negative times a negative will become positive. And then we have our c value, which is 19. Okay, 19. And then we're just simplifying from there. So what is it that you get when you simplify all that? Let's see. I'll pause that while I do some calculations. Okay, so let's walk through some of these simplifications I just did. So 16 squared gave us 256, and then negative 4 times 4 is negative 16. Negative 16 times positive 19 gave us negative 304. So then the 256 minus 304 give me a negative 48 underneath the radical sign. And this is an even root, which means you can't have something that multiplies times itself or to an even power and get a negative. It does not exist in the real number system. So we know that now we're going to have two imaginary solutions, one for the plus and one for the minus. So remember that the imaginary root, or imaginary unit I meant to say, I, is the square root of negative 1. So I've just rewritten the negative. I've taken that out from underneath the radical and put it outside as the imaginary unit I. In the next step, I realized that 48 had a perfect square factor. 16 divides into 48 3 times. 16 times 3 will give you 48. So that means that the square root of 16 can come out. And then we're down to one last step to simplify this, and that's looking to see if the two terms in the top have something in common, have a common factor with the denominator, which they do, because all of these numbers, 16, 4, and 8, share the common factor of 4. So if I divide all of these by 4, I'll have my simplified result, which is, let's see, 16 into 8 is 2, plus or minus 4 over 8 is 1/2. So I can write that as the square root of 3 over 2, and then I, right? So those are my two solutions from that part of it. And let's see, yeah, 2 plus or minus the square root of 3 over 2i. Yeah, see 2 plus the square root of 3 over I and 2 minus the square root of 3 over 2i.